And this is nomenclature. Nomenclature. Okay, so nomenclature is going to be naming. We're going to be naming organic compounds, and there's a very systematic way of doing it. And it's going to be much more involved than probably what you learned for salts in general chemistry. So a lot of this is going to be self-paced practice, practice, practice. So what I'm going to do is I'm going to walk through the rules with you using the handout that's on Blackboard. And I'm going to open that up in just 1 second here and show you how to use the handout to do naming. But it really is, unfortunately, you got to get in there and try it and mess it up and try it again and figure it out. Okay, but I'm here to help you through that. So there are some rules to follow when it comes to naming your compounds. All right, does everybody have the handout near them, someplace they can see it? Okay, it's on Blackboard. All right, so the first thing that you're going to be doing is you're going to be looking for the longest chain to give the molecule its root name. Okay, so the root name is going to be based off the number of carbons. So for example, here's a molecule right here. If I'm looking for the longest chain, I should also say carbon chain, what I want to do is be able to start with my pencil on one end and see how many carbons I can get to without picking my pencil up. Okay, so if I start here and go 1, 2, 3, 4, 5, 6, okay, that's one chain. But I could also go 1, 2, 3, 4, 5, 6, 7. That's a longer chain. You could go 1, 2, 3, 4. Those are all chains, but only one was the longest. So in this case, 7 is the longest chain. Okay, so 7 is going to be giving me the root. So at the bottom here, what you'll see is a list of prefixes that are going to be giving us the basis for the root of the name. So we just said that our molecule had 7 carbons. So that means we are going to be down here. The root of our name is going to be het. Okay. Everybody with me so far? Okay, so I'm going to go back up to my example here, and the root is going to be hept. Okay, now that's the root. So we're going to have 2 places that we're going to be adding things on to this root. We're going to have prefixes, and we're going to have suffixes. No, you did not go into English class today. All right. The prefixes are going to tell us about substituents. You guys remember what substituents are? They're things that are attached to the chain. So prefix is going to tell us about substituents. Substituents. The suffix is going to tell us about the highest priority functional group. Let me write that down. Highest priority functional group. Sorry, that is my abbreviation for functional. Okay. So that means that we're going to need to know a few things. We need to know what our functional groups are. I would definitely know those for Wednesday. Hint, nudge. Okay. And we're also going to need to have some type of a priority list. Okay. At first, you're not going to need to memorize this list. You'll be given a list of priority. Okay. I'd rather you spend your time learning the functional groups and how to apply the rules than necessarily memorize all of them. Okay, so I'm going to go back onto our example here, and I'm going to add a functional group. And I'm going to add a functional group that is here. So I'm going to add a double bond to an oxygen. Okay, so I added it right there. Before that, I just had alkane, saturated hydrocarbon. That's all I had. All right. So I'm going to add a functional group. Does anybody know what functional group this is? Carbon oxygen double bond with 2 carbons on either end.
Ketone.
Ketone, awesome. This is a ketone. Okay. So step 1, we're going to find the longest chain and give it a root name. We did that. 7 carbons long, and we're going to call that hept. Identify the highest priority group and add its suffix to the root. So we're going to need to go down here and look at our functional groups. So I'm looking under functional groups. I'm going to look for my ketone. Look for my ketone. Ketone right here. Okay. So the root that it's going to give me is one, O-N-E. So this generic form is showing you the root, which is your alkane, plus a suffix. So it's saying I'm going to take my root plus O-N-E. So I'm going to go back up here and say, okay, so let's grow on this. We had hept. The suffix is going to get the O-N-E from the ketone. So now we're at heptanone. Okay. I feel as though I need to take a step back first, because you might be wondering where this AN came from. Okay. Let me take a step back. We had 7 carbons. That would be hept. The all carbon form adds A-N-E there. So heptane would be the all carbon form. All right. If it was 1 carbon, that would be methane. So remember, we just did an example where I drew methane for there are 4 things attached to this carbon. So we're going to take, I'm going to go back down here. It wants us to take the root, which is hept, the ane, drop the E, and add O-N-E. Do you see that? So we dropped the E. Ooh. I have another handout that writes all of that out, drop the E, add this. I'll add that into the folder if that's an additional help for you. It's a little bit more wordy, which is why I didn't put that in there at first, but I think it might be useful. Okay, so now we're back up here. We're at heptanone. Okay, there's a couple things we need to figure out how to explain. One, how do we explain which carbon that ketone is on? So if I just said to you heptanone, you could have put the carbonyl, the carbon oxygen double bond on this carbon, on this carbon, on this carbon, and they all would have been heptanone. So we need to have a way of saying the ketone is at carbon 2. Okay. We also need to describe this 1 carbon substituent that's attached as well. So let's work on that part. So we just finished number 2, which was identify the highest priority group and add the suffix on. Now we're going to do number 3, which is identify substituents and number the carbon of the longest chain beginning at the end closest to a substituent. Okay. You always want to have the lowest number combination possible. want lowest combination of numbers possible. And I'll show you what that means right now. Okay. So we all agreed that the 7 carbon here chain is our longest. So I want to number it. And I'm going to number it with 2 different colors so we can figure out which one is the best one. Okay. One of them I'm going to number from left to right, and the other one I'm going to number from right to left. So 1, 2, 3, 4, 5, 6, 7. Or I'm going to start at the right end. 1, 2, 3, 4, 5, 6, 7. Now, if I want to describe where the ketone is and where that 1 carbon piece is, if I number according to the green numbering, I would say that this 1 carbon piece is at carbon 5 and that the ketone is at carbon 6. So I would get the numbers 5 and 6, right? If I numbered according to this, I guess this is a dark purple color, I would say the ketone is at number 2 and the methyl group is at number 3. So I get a 2-3 number combination. 2-3 smaller than 5-6. Okay, so we're going to want to go with that dark purple color numbering because we get the lowest numbers possible. Should I say that again? Okay, if I use the green numbering here, my substituents are attached at carbons 5 and 6. Okay, those are pretty high numbers. If I use the darker numbering down here, my substituents are at 2 and 3, lower numbers. So we're going to go with the darker numbering because it's the lower numbers. Okay, so I'm going to go ahead here and I'm going to erase the green. And we're going to go with these lower numbers. How's that sound? Does everybody see how we picked it? Okay. So we're almost there. Now we need to figure out how to deal with those substituents. So right now we have our main functional group and 1 substituent. And we want to arrange the substituents, if we had more, in alphabetical order. But let's just work with our 1. Here's our 1. How do we name it? Well, we're going to name it in a similar way as if it was any other carbon-containing piece. So how many carbons are on the substituent? 1 carbon, right? So it is going to get a root. And the root for 1 carbon is meth. Okay. It is just an alkane, or it is an alkyl group. So we're talking about an alkane. We're going to use the prefix ending of YL. Another way of saying that is, since this is a substituent and it's going to be part of our prefix, the meth becomes methyl. So now our meth becomes methyl. Okay, it is a methyl group attached to the heptane chain. Okay, different than if we had this. This is a 1 carbon group, meth. There's nothing else on it, so it gets the ending ane. So this is just methane. The methyl group is this alkyl group hanging off the main chain. Okay? Now, I like to kind of make a list of my substituents on the side and then put them together. There's only one in this case. So for this example, we'll just write it with the name. So we want to say that we have a methyl group. That methyl group is attached at carbon 3. So we would say 3. And we need to separate numbers. Okay, we want to separate numbers from letters, and we're going to do that by using this dash. Okay, so we're going to say 3 dash methyl heptane. And now we're going to name another number to tell us where the substituent is. Okay, so the substituent is on carbon 2, so we're going to use dash 2 dash ONE. Okay, so this whole name for this molecule is 3-methyl heptane 2-one. No problem. I'm kidding. It's not an easy thing to do. It gets easier with practice. Okay. Good. We're gonna do a couple of examples if that's okay. Do you mind if we do a couple? And then I'm going to show you the secret of going the other way. So this is essential learning outcome 4 that we're working on right now. Okay. So I'm going to go back to our notes. Keep that handy. And see handout. Okay. So let's do this one. Okay, I'm going to pause. Make sure you guys have time to write it down. Okay, we're good? All right, so let's go through the steps. Let's identify our longest chain. So start anywhere you want and go along your molecule until you find the longest chain. 2, 3, 4, 5, 6. How many carbons did you find in your longest chain? 8. I'm seeing some people mouth 8. Did you get 8? All right, so look on your root list and what's 8? If you look on your handout, jump back and forth here. If we go back to our handout, 8 is going to give us oct. And we're going to add ane to the end of it. 2, 2, 2. Oh, nope, no, come back.
Why do you add ane to the end of it?
Because we're going to start with ane because it's our carbon chain, and then we're going to adjust it for any higher priority functional group. Okay, so 8 is oc, and we're going to add ane to the end. Oh, ane to the end. Okay, if you ever want to know what high octane fuel is, it means it has a lot of 8 carbon chains of hydrocarbons. All right, functional groups. Do you see any functional groups? Yeah. Okay. Anybody feel brave? Want to tell me what it is?
An
It's an
alcohol?
alcohol.
Alcohol. Okay, so now let's go to our functional group list and find what the suffix is when that is the highest priority group. So we're going to go down and you'll notice that these are listed in priority. Okay. So if you have two, so let's say we have a ketone and alcohol, we're not sure which one is the highest priority group. Wherever it is on this list is going to tell us. So alcohols are 5th on the list. They are a lower priority than ketones are. Okay, and I'll show you how to handle that in just a second. So if we have an alcohol, the suffix is going to be OL. So we're going to take the alkane name, drop the E, and add an OL. Da, da, da. Okay, so we're going to drop the E and add an OL. So now we are at octanol. Okay. So far, so good? All right. Now let's look for our numbering. Okay. So our numbering, we have a couple ways that we can number, right? We can number 1, 2, 3, 4, 5, 6, 7, 8. Or we can number 1, 2, 3, 4, 5, 6, 7, 8. Let's see what number combination would be the lowest. If we use the green numbering combination, we would have something attached at 4, we would have something attached at 6, and something attached at 7. Do you see how I got that? Yeah? If I use the pink numbering, I have something attached at 2, 3, and 5. All I did was I looked at this chain and I looked for spots where I had things attached, and I looked at what the green number would be and what the pink number would be. Which numbering system do you think is better? Which one gives the lowest combination of numbers? Green or pink? The second one, the pink one? Good. So we're going to use the pink numbering. So we're going to forget about the green. We're going to use pink. So now let's look for our other substituents. All right. So at carbon 5, we have a 2-carbon piece. How are we going to name the 2-carbon piece? How are we going to do that? Okay, I'm going to jump back. Sorry, I wish there was a faster way I could do this for you. Okay, we're going to jump back and say, all right, I have a 2-carbon piece. Eth is going to be the root, and it's going to be the substituent, so I'm going to add YL to it. So off to the side, oh, it's jumping around on me here. Hold on one second. So off to the side, I'm going to say at carbon 5, I have an ethyl group. Okay, so that takes care of that one. At carbon 3, I have a 1-carbon piece right here. What do we call that 1-carbon piece? See if you can find it. 1-carbon. 1-carbon is meth. So we're going to give it a methyl, and it is at carbon 3, methyl. Okay. At carbon 2 is at OH group, but we've already accounted for it in our suffix. Okay, so it's not an additional substituent because it's already given us the suffix. All right, so now we have these two. So the question is, do we put them in order by their number, or do we put them in order by their name? And they're going to go in order by their name. So we're going to arrange them in order. Here we go. alphabetically. Okay. Hop back. Okay. So that means the first one is going to be the ethyl group. That's going to be the first one we name. So let's go ahead and just write our name. 5 dash, because we have to separate numbers from letters with a dash. Ethyl. Now we're going to say 3-methyl. We have to separate letters from numbers again. So it's dash 3 dash methyl. Now we can put our root and suffix in right here. Octanol.
I have a question.
Yeah.
So do we indicate where the alcohol is?
Yes. Thank you. I almost forgot. Do you guys see what I did? Awesome. Okay, so please correct me. Where do you think it goes? Where would you put it based off of what we did with the ONE in the last one?
Would it be like octane like -2
Yeah, high five. Exactly. I'm going to erase the OL right here. I'm very sorry. -2 OL. Now, I must be honest, some people will move this number 2 around. Some people will put it in front of the root, and some people will put it right in front of the suffix. It is more correct to put it in front of the suffix. Okay? But just to warn you, that's kind of one place that people will change things up. Thank you very much for catching that.
I have 2 questions.
Yeah, please.
First is, what did you say about putting ethyl or methyl first?
Mm-hmm. So we add these alphabetically.
Okay.
Oh, come on. Go ahead.
And then
I think I spelled it right.
For did you know that the OH group was going to be the is it the prefix? No, the suffix, because it's the highest functional group.
Exactly.
Okay. So then did you just like automatically know to start with that because you knew that it was going to be the highest group?
So when I looked at this particular molecule, I noticed that there was nothing on the molecule besides saturated hydrocarbons or alkanes except that OH group. So it kind of stuck out at me as the highest priority group because that was the only thing above an alkane present.
Okay, thank you.
You're welcome. All right, let's do another one. Okay. All right. So we have a couple things going on here. But first, let's just start with what is the longest carbon chain that you have here? How many carbons do you have in your longest chain? Okay, I'm seeing a bunch of different numbers. Let's take a look. I'm going to start here at this carbon. Remember, the longest chain has to be all carbon. So if you got something longer than this, you may have counted another atom. So we have 1, 2, 3, 4. So if you came up with 6, you may have gone to bromine and oxygen. Once again, just make sure it's the all carbon chain. If you got lower, you may have missed this one right here. It's a common one to miss. So we have 4 carbons. What is the root for 4 carbons? Take a look at your list. I'm sorry if you can hear my dog. She is snoring so loudly. Can you hear her a little bit? You'll hear it. Abby. Anyway, okay, 4 carbons. That is bute. And for carbon chain is butane. Okay. So we have 2 different types of groups attached now. We have a halide group. We have 2 of them. And we have this carbon-oxygen double bond with an OH group. And that one is, somebody know?
Is that carbol? I can't say it.
Yep.
Carboxylic acid.
Yeah,
Okay.
carboxylic acid. Good. Awesome. So let's take a look at our list. Where do you see halides? They're going to be called alkyl halides because they're attached to carbon groups. Do you see that yet? Alkyl halides. Are they high priority or low priority? They're super low. They don't count any more than just a carbon group would. But let's look at let's look for carboxylic acid. You're going to need to go all the way down because it's going to be our highest priority group. So if you see the carboxylic acid, it wins. Okay. So it has a 2-part kind of suffix to it. It has oic acid. So the generic form is that we're going to take the alkane, we're going to cut off the E, and we add oic acid. Okay. So this root plus suffix becomes butanoic acid. Something you really don't want to smell. It smells like old sweaty gym socks. It's gross. Seriously, it does. Okay. So the carboxylic acid is always going to be at the end. Okay. It's always going to be at the end of a chain. So we don't have to give it a number because what's understood is that it will be number 1. And let me jump back to the other one so we can make a note on it. So I'm going down here to the carboxylic acid. So the carboxylic acid takes priority over any other group that you have, and it is going to be carbon number 1 of your chain. Okay, even if the other things give the highest, give a higher number than you would necessarily want, it's always going to be number 1 of your chain. Okay. And you'll see that a lot with some of these high priority groups. Nitrile, you'll also see that that gets the carbon 1 of our chain. Aldehydes will also get carbon 1 of our chain, and we'll talk about that. Okay. So that's going to take one step away from us. We don't have to worry about numbering because that's going to be number 1, 2, 3, and 4. Okay. So now we need to talk about how we're going to talk about these. That was a lot of talk about how we're going to label where these bromo groups go. Okay. So if we go back up to where it says alkyl halides, you'll see that when it's a substituent, so underneath the prefix column, it is going to be either iodo, bromo, fluoro, chloro. So if you think, you kind of take the name and you drop the INE from it and you add an O. So for example, we take bromine and we're going to drop the INE and add an O. So this becomes bromo. All right. So how many of them are there? There are 2. Okay. So we're going to use another prefix to talk about 2. Okay. I know. I'm telling you, this can get there's a book about this thick just on how to name organic compounds. So we're going to keep it at the beginner level, if that's okay with you guys. Beginner level. All right. So if we have multiples of something, we're going to use for multiples. We're going to use some prefixes. If there are 2, we're going to use di. 3, we're going to use tri. 4, we're going to use tetra. And you're going to see we're going to use those adjectives or those, yeah, I guess they're kind of adjectives a lot. We're going to talk about tri-substituted and tetra-substituted a lot during the semester. Okay. I don't know what happens after 4. I've really only seen it after up to 4. So I guess it's something I should look up at some point. All right. So we have 2 bromines. So we're going to say this is a di-bromo substituted compound. Okay. But we have to talk about where those bromines are. Where are the bromines? On carbon 4, right? Good. They're both on 4. So we're going to say that we have 1 on carbon 4, comma, another 1 at carbon 4, dash. Because we could have a dibromo and them being on carbon 2 and 4, or 3 and 2, or any combination thereof. So each substituent gets its own number. Okay. So we have everything now. Let's put it together. So we're going to have our substituents for dibromo butanoic acid. Okay, and remember, it's understood that the carboxylic acid is at carbon 1, so you don't have to number that. Do you feel like you need another example? Yeah. Okay, no worries. Okay, so let's do another one. I'll leave that up there. Let's do actually, let's add in a chloro here and a chloro here. So if you're just drawing, I just added a chlorine here and a chlorine here. Okay, it looks crazy, right? But I want to show you, we're just going to follow the exact same rules we did a second ago. So one of the reasons I wanted to do this is because you notice the longest carbon chain doesn't necessarily go straight. It starts to curve and go in different directions. Don't get fooled by that. It doesn't have to be straight, because in reality, these molecules are spinning around and spinning around. So the fact that it kind of goes down here, don't let it fool you. It's still connected. Okay. So our longest chain, if we start here or at the other end, doesn't matter. 1, 2, 3, 4, 5, 6. That's not the longest. 1, 2, 3, 4, 5, 6, 7, 8, 9. That's my longest, right? So our root, I'm going to move this up now. Our root, we're going to go back to our list, and our root is N-O-N, non, and we're going to add ane to it. Non-ane. Hardest one for me to say, non-ane. Okay. And now let's identify functional groups. We have some halogens, we have chlorines, we have bromines, but we just said a second ago, they are very low on the priority list. But we have two other ones. We have an OH group, and we have this one, which is carbon-oxygen double bond, but that carbon has a carbon and a hydrogen attached. What is that called? What's that one called? This is an aldehyde. Okay, so an aldehyde has a carbon-oxygen double bond with a hydrogen and some kind of a carbon group attached. Different from a ketone, because your ketone has 2 carbons attached. Your ketones can be anywhere in the chain except the ends, and your aldehydes have to be on the ends because they have that hydrogen. So aldehydes also are going to be understood to be at carbon number 1. Yay. Okay, whew. So now we're going to take a big breath. 2 priority groups. Which one's a higher priority? Alcohol or aldehyde? Going to look at our list. So alcohols are number 5. Aldehydes are number 7. So aldehydes are going to be higher priority. So what is the abbreviation that aldehydes give us? I'm sorry, the suffix that aldehydes give us. They give us AL, right? Do you see that on your list? Alcohol gives OL, aldehydes give AL. Okay, so we're going to drop the E and we add now AL. So this becomes nonanal. Oh my goodness. Nonanal. Okay, not the easiest thing to say. All right, so let's go ahead and write some numbers in to help us. Let me use a different color. 1, 2, 3, 4, 5, 6, 7, 8, 9. So let's go ahead and make a list off to the side of our substituents. Once again, I make the list because we're going to need to alphabetize them when we put them together in the name. So if we have them not in a string, it makes it a little bit easier, at least for my brain, to alphabetize them. All right. So where do we start? It doesn't matter. Doesn't matter where you start. I just like to kind of go along my row here. So as I move over here, I have an alcohol at carbon number 2. So now the alcohol is a substituent. So what is it called when it's a substituent? We want to go to our handout here. When it's a substituent, it's going to be called hydroxy. Okay, so an alcohol, when it's a substituent, is called hydroxy. So go back. And on my list, I'm going to say at carbon 2, I have a hydroxy group. Okay. Now also at carbon 2, I have a chloro group. You can handle this however you want to. You can list each of them separately and then add them together. Or you can do it this way, whatever works for you. I have a chloro. I kind of scan and I notice there's 2 more of them. We have one at carbon 2, one at carbon 3, and one at carbon 5. So I have chloro, and I have 3 of them, which means I have a trichloro. Okay, where are they? There are carbon 2, at carbon 3, and at carbon 5. Does that make sense what I just did? If in your substituent list you wanted to say 2 chloro, 3 chloro, 5 chloro, and then combine those together, do it that way if that helps you. Okay. I'm going to continue on my list here. Oh, I got to something I haven't counted yet, which is the bromine. I only see 1, so I have 4 bromo. Okay. I'm going to continue on. 5, I got the chloro. Oh, I have this group right here. 1 carbon group. That's a methyl group. And that is at carbon 5. Okay. Do we have all of our substituents now? Are we good? All right. So now we need to alphabetize. One note here. The di, tri, and tetra do not come into play when we alphabetize. So when we alphabetize, we're going to look at the H, the C, the B, and the M. I don't know why they did it that way. That's just how they did it. Probably because you could have like 15 try somethings in a molecule. Okay. So now we have everything. We have the prefixes, the root, and the suffix. Now we just have to put them in order. So do you want to try to do it on your own first and then I walk you through it, or you want me to walk? Okay, go ahead. Take a minute and try to do that. Remember, you're going to alphabetize these and then add your ending. Good. All right. So for time, I'm going to write this out, okay, as opposed to having you write it out or walk me through it. But please stop me if you want me to explain anything that I do. All right. So I'm going to do my substituents first. I'm going to do them in alphabetical order. So the first one is bromo. So I'm going to have 4. Oh, I need a pen here. I have 4 bromo dash, and I'm going to put a little check mark because I did that one. Next one is C. So I have 2, 3, 5 trichloro. Did that one. Next is H. So I'm going to have dash 2 dash hydroxy. Did that one. Last one is dash 5 dash methyl. No, oh, there shouldn't be a space there. I don't want you to think there is a space. Nonenal. How'd you do? Awesome. Okay. If you get yourself a system and keep that system, then you're going to do really well. But it takes practice. I'm not going to lie to you. It takes practice. And then there's a little nuance that'll come up every once in a while, like, oh, well, we don't count try when we do the alphabetizing. Okay. All right. Now let's go the opposite way. I'm going to give you a name and we're going to draw it. Okay. You should not be scared of this. This one, I think, once you have the trick, that took me until I was teaching this the first time to pick the trick, you'll be okay. So here we go. I'm going to make up a name. Let's say we have 2,2 dash dibromo dash 4 dash propyl dash oh no, I picked something too long in the alphabet. 4 propyl undeca 3 own. All right, draw it. Go ahead. No, I'm just kidding. Okay. Here's the secret. When you go to draw this, go from right to left, not left to right. I don't know why it never clicked for me, but when you're building this structure, start at this end and go backwards this way. Okay, so meaning this. Start off, what is my root? Undecane, and my highest priority group is something that gives me an own and is at carbon 3. So let's look at our list. Undeck tells us how many carbons? Undeck.
11.
11. So I'm going to draw 11 carbons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Doesn't matter if you point it up first or down first, as long as you have 11. Okay. And at carbon 3, we're going to put the group that gives us O and E. So first of all, where's carbon 3? Is it on the right or the left? Doesn't matter. It's wherever you want it to be. So if you can number from the right, you can number from the left. You're setting this up. It does not matter. 11 is down here. Okay. So what is going to be the group that gives us O and E?
Ketone.
Ketone, good. So this is where knowing what a ketone looks like is going to be really important. I did not mean to take all of that off. There we go. So a ketone means I'm going to have a carbon-oxygen double bond on my chain. So carbon 3, 1, 2, 3, I'm going to put my double bond to an oxygen. Remember, I could have easily put it over on this side. Doesn't matter. I'm defining where carbon 1 is, if it's on the left or the right. Well, guess what? You're done that whole part of the molecule already. Now watch. Go chunk by chunk and forget about everything else. So here's my next chunk. Carbon 4, I have a propyl group. So carbon 1, 2, 3. So here's carbon 4. How long's a propyl group? YL tells me it's all carbon and hydrogen. Prop tells me how many carbons? 3. So attached here, I'm going to draw 1, 2, 3. It doesn't necessarily have to look like that. It can be going the opposite direction. It could be making a U-turn. Doesn't really matter. Okay, we're done that one. Now we go to the next part. Do you see how I'm taking a number with a group that's defined by that number? That's my chunks. Okay, at carbon 2 and at carbon 2, I'm going to have bromo groups. Here's carbon 1, here's carbon 2. I'm going to have 1, 2, and you're done.
When you said go right to left, I thought you meant when drawing the structure. So does it matter if ours is like on the, like all the stuff is on the right side?
Absolutely not. You could have this. 4, 5, 6, 7, 8, 9, 10, 11. You could have something that looks like something like that. Yep. Which is why when we do that numbering at first, when we're like, well, let's figure out if we go right to left or left to right, when we're doing it this way, from the structure to the name, we have to check both ways because it could be either. Not so bad, right? Okay, so that's the secret for doing it from the name to the structure. And I'll give you lots of practice problems. The secret is from the name, you want to start at the right-hand side of the name, do the root and the suffix first, and then break these into little chunks where you have a number and a substituent together. Not so bad, right? Just don't get yourself kind of caught up on the, where's the number one going to be? Where is does it go from the right or from the left? Because you're able to make those decisions and it doesn't matter at that point. Everything's relative to how you start. Cool? All righty.